So let's get started. So the topic now we are going to discuss is context. So there is a package named context in standard library of Golang, which provides us a type context. So as the name suggests, it is just passing around context in our application. So this context package and its type is useful in cases where we are handling with HTTP requests or any sorts of request and response structure. So at that time, when we want to pass around some value related to request, like some important value like request ID related to request or some details of the request, at that time we can use this context package and its type. So you can get the documentation of this context package at the following place. I have attached a link to it. So since it is kind of an advanced concept, we will not go too much deep into it because there will be few concepts coming in the upcoming sessions, which are Go routines, channels, and HTTP programming in Golang. So at that time, you will get to know some basic stuff, which are the prerequisites for understanding concept, a context. But for now, we will just go through it briefly, and we'll see what are the main tasks or concerns that context package handles. So generally there are two things which are mainly handled by context, and they are context cancellation and propagation, and second is request scoped values. So while talking about request scope values, we can say that when we deal with HTTP requests, so there is a possibility that HTTP request can go very deep. So consider with the help of an example. So I am at a restaurant, okay, and I am giving an order uh, to get me a sandwich, okay. So in order to get the sandwich, they will take the request from me that I want a sandwich, and after that they will subsequently like perform some actions related to it in order to make a sandwich. So there is a possibility that that sandwich needs a tomatoes, and tomatoes are not there. So the chef could ask vendor to get tomatoes. So what is happening here is the context related to request is getting passed around from one place to another, like from me to chef, then chef to uh, chef to the vendor, which is getting him the tomatoes. So at that time, this values should be propagated all together from one layer to another. So this is where this context cancellation and propagation is helpful. So if I want to cancel my order, so it is important for the chef and vendor, for both of them to know that I have cancelled the order. So when I cancel the order uh, to the chef, he will know that the order has been cancelled, and further instruct the tomato vendor also that we do not want the tomatoes anymore because the order has been cancelled. So this is how we in general handle the cancel and propagation. So similar we want to do with HTTP requests as well when we are dealing with it in a programming language. So when we are working with applications and we deal with HTTP requests, we need to also consider the cancellations as well, because we are putting valuable resources into action in order to perform some specific task. So consider I am requesting for some resources, which is sending me a huge file after processing it. So what happens is my backend application is working on like building that file, and it is deploying some important resources to get that file created and send it to me as response. But what if the request is cancelled in between? So at that time, the our application program should know that that request has been cancelled, and at that time the resources which are deployed in order to uh, give a response to that request should also be cancelled. So this is how cancellation and propagation should work in our applications as well. So that's where context package is very helpful, and there are some request scoped values which can be useful while working with HTTP request, like if I am like working on a request, so it must be helpful to have a request ID associated with particular request and print it in the logs, so that I know that this particular log belong to a specific request. So in that case, request scoped values are also helpful to us, and can be these two can be achieved with the help of context package in Golang. So you will get to know more implementation details in further sessions. So we are here just discussing the brief overview of this topic. So generally, there are two functions in context package that allow us to create context object, and one of them is context.todo. This creates an non-nil and empty context for us. Okay, so if you want to go through the documentation for it, you can visit this website and you can check out what do we mean by non-nil empty error. You can go through the code as well, that go through the source code as well, that it is creating an empty context for us. So as we can see, this is a new method is called an empty context variable is assigned, and this has been sent back to us. And similarly, we can create context using context.background method as well. This is similar to context.todo. This also creates non-nil empty context for us. But the difference is the intention here. Both of them have same functionalities, but context.background we use when we want to create more context out of it, when we are sure that we will be using this context. And context.todo is used when we are not sure that we will be receiving context from some another function, like as we talked about propagation of context in the previous slide, that we can like send the context layer by layer deep into our request. So if we are not sure that we will be getting context in some layer, so at that time we can use context.todo. So at just as a placeholder, even though functionality is same, everything is same with both context.todo and context.background, just the intention is different behind using those. And there are four main functions related to the task which we just saw, which are context cancellation and propagation, and context having request scoped values. So in order to assign request scoped values to our request context, our context, we have with value function. So what this with value function does is, it takes a context as an input and it takes a key value pair, and it then attaches this key value pair to this context which we passed and created a new context out of it and return it to us. So just like I sent a burger and I wanted like a tomato slice in it. So I'll like just in the case of request, I'll also mention the key value pair, that whatever value I am assigning against the key. So if I want to have the request ID in my context attached, so I will use the key as request ID and I'll assign the value of the request ID in the context, and we'll create the new context out of it. So this newly generated context will now have this key value pair fit within it. And these three functions which we see at line number 2, 3, and 4, which are with cancel, with deadline, and with timeout, what these three functions do is, these three functions take care of cancellation and propagation part. So in order for us to able to cancel the request with the help of context package, we create new context, child context, with the help of these three functions. And we can set deadline to it, like after how much time, after at what time exactly our context should expire. And with timeout function, we can like create a context with the timeout, that after 30 minutes or after 2 hours of processing, our context should expire and should further process no more okay in the request. So these four functions are helpful with these two particular cases, that is request scope values and cancellation and propagation. So you will not have to use it anywhere, or you will not get to program with it until you get the hang of HTTP programming in Go. But just in case, for your knowledge, just keep this in mind that with value is related to having request scope values. We can add key value pair to our request context, and this other three, with cancel, with deadline, and with timeout, these are related to cancellation and propagation. So with the help of this, we can cancel or timeout our context. So yeah, as I mentioned that whenever we were using those functions with value, with cancel, with timeout, we were creating new context out of it, because context is an immutable object. We cannot like update the values in the context type. So we will always have to like create a new context around a parent context and add more data to it. So if I had a request context earlier and I wanted to attach request ID to it, so what I do in this case is I use the with value function, pass the parent context to it, and I assign the key value pair. So it will result in creating a new child context with additional data. And you can wrap around your context multiple times, and it will be it can be kind of represented into a tree structure. So let's look at it. So uh, what I'm trying to do here is I am trying to create a context which consists of few things. So let's go in the very innermost function what we are doing. So first thing what we have is we have context dot with value. So in the context dot with value, what we are doing is we are passing in non-nil empty context using the context dot background. So at the very top, at the very top of hierarchy, you can see that we have a parent context. Okay. And then after that, we have added a session ID to that particular context. So at that time, we have got a new context, child context with session ID. So this is at the second part. And after that, this function returns a new context, this context dot value, and it will be passed on to this with deadline function. Okay, so this with deadline function will add a 30-minute deadline to the earlier created context. So now our context, which had session ID before, also now has a deadline of 30 minutes. So we have successfully added a deadline to it and created a new child context again. So you need to understand the hierarchy that we had a we had a parent context we created using context.background. Then after that, we added a session ID and created a new child context. After that, we passed on that new child context and created a new context with deadline. And again, what we are doing is we are passing that child context to context.withValue function, and we are adding request ID to it. So here we have created a third child context, which has all the value from before, and additional to that, we have a request ID also. And this particular child context at the fourth stage, which has session ID, request deadline, request ID, it is being sent to two different functions. One of them is trace function and one of them is logger. So we can like pass around the context as well to the different functions after assigning values and deadlines to it. So this is how a tree structure of context would look like. And in order to understand the hierarchy, we can say that context represented as a directed graph. Each child context has access to values of its parent context. So as I mentioned that context.background did not have anything, but the context.session added a new session ID. So after that, when we use this particular context in the request deadline part, the session ID was also accessible here. So at the very end, when we pass on context to this zipkin trace and request logger, we will have all three values in the context, that is session ID, request deadline, and request ID. So we can have access to values from parent context, and data access flows upward in the tree. So as we can say that this is the parent context and these are the child context. So we can say that data access hierarchy goes upward, so that request logger context will have the access for all the data upwards. Request context at this place at point of request id had the data access of session id request deadline. The context at point of request deadline had the access of session id. So this is what we mean when we say data access flow upward in the tree. And opposite to that, cancellation signal travel down the tree. So consider if I cancel the parent context, so the child context will also get cancelled along with that. So if I create a context dot background, and then after that subsequent contexts are created using it. So if I cancel this parent context, so all this contexts which are created below child context, these will all be cancelled. So as you can see, this cancellation flow is represented by gray edges, and data access flow is represented by black arrows. So let's look at a simple example. I'll just show you. So what I have here in this case is I have a client program. So I have a server which runs a HTTP server on my local system. So I will just do that. Okay, so it was already running. So let me do it again. So consider this is an HTTP server, like our application server, which is running. And I have a client. Client, that means whoever is calling that whoever is making HTTP request to that server. It can be browser, or it can be any client program sitting on other server. It could be anything. So generally when we like access websites and web application on browsers, so browser is the client there. So for just an example, you can consider this client as browser as well. So what this client is trying to do is it is trying to access the server at port 8080, and we will just see what is there in the server code. So what this server does is it takes the request, waits for 5 seconds, and then returns hello to the client. So we have started the server, and we will just run the client. So what this is doing is this is sending the request to server, waiting for 5 seconds, then the server is returning hello. Okay, so this was simple because this had only simple few things that we were able to send the request and we were able to get the response. But now we will see an example of context cancellation. So here my request had context cancellation as well. Okay, so in this particular program, what I am trying to do is I am adding a context with timeout here, which will time out within a second. So as we know that our server is taking 5 seconds to send the response. So if my server is not sending the response within 5 seconds, within 1 second, so what this will do is this will time out and cancel the request. So let's try to hit that. So yeah, as you can see, it is showing that context deadline exceeded and it has exited the program. And on the server logs as well, you can see that server had request had started, but the context was cancelled in between because we timed out and the server ended the processing. So this is a general use case where like we can have context and we can use context cancellations. So yeah, this was a brief idea about context. You will get to know more about it when you will be looking at the HTTP programming in Golang, and some few more concepts like Go routine and channels, which like plays their part in background in order for context to work. So yeah, this was all about context. So further session will be carried on by Sushmita. Sushmita, you can take over. I'll stop sharing my screen now.
Yeah.
For reference, I'll share the code as well with you guys, just so you can just try it out for now. But you will get a clear idea when you go forward with other concepts. Okay.
So this was a bottleneck.
This meeting is being recorded.
Okay, so this was the bottleneck in Golang because it was not having any dependency management tool. So this type of issue also come into the production environment, and the community started uh, looking for the more approaches for the dependency management. So the Go models was introduced in Go 1.11 version. So prior to this, there was like vendoring and the dep, which community, it was a third party tools, both were the third party tools, and community was using them for the dependency management. So the vendoring and dep are being deprecated and they are not being used now. But let's just to give you more information about it, there were like pros and cons for vendoring and the dep. So what does vendoring concept does is like it creates a vendor folder into your code, and it stored all the third party dependencies into that vendor folder. So what was the pros with this approach is like whenever you try to build your project for the deployments, all the necessary dependencies were already present in the vendor folder. So the like the building type or the deployment time got significantly reduced. But there were many cons with this approach because it increased the code size of your project. Let's say the code size of Golang, the code size is, let's say the file size is 1 MB. The dependencies would be more than that. Like it would be usually more than 5 MBs because of storing all the vendor file code in your own projects. So there was also one of the con, like the multiple versions of the same package you were not able to use in your project. Let's say I'm using package X, and some of my dependencies are using 1.1 version and the others are using 2.1 version. So this was not possible using vendoring. Then it was not a good practice to make the third party dependencies part of your code. And also the upgrading and downgrading the dependencies was bit difficult. Then we use the tool called dep. So dep is a third party tool, and it is being used by many programming language. So it was also used by Go. So what dep does is like dep manages a dep file which has the versions of each dependencies. It was a much cleaner way of managing dependencies than vendoring, but it also had some of the cons as it needed to download the dep in your own system. Like you had to install and download the tool first and then start using it. Again, the one more problem with this approach was if you had any interdependencies, let's say we are using two repositories, let's say two repository X and Y, and both X and Y are also using a third party tool as Z. And let's say X is using the version of Z as 1.1 and Y is using 3.1. Then in this case, this scenario was not possible to handle using the dep. Also, the dep file is not much descriptive to understand, like how does it manages the dependencies. So I think because of this multiple cons for the vendoring and dep, so the Go modules was introduced. So what is